Hello all, welcome to my channel. I'm back with a new video. In this video, we will discuss how Iceberg supports deletes. So in one of my previous videos, I had shown uh, how tables, when we issue a delete statement, how it handles and how it creates a new delete file. So that I had discussed briefly. In this blog, we will see it in full how it works. So when we delete a record from an iceberg table, the data is not removed physically from the file. There are multiple reasons to do that. One is delete. If we remove the data, we can't recover it back. Uh, that is one. The other one is, let's say if we are removing a file, removing a record from a file, which is, let's say, 100 records. So just to make one record delete, it's not that we can go ahead and delete. We don't have an eraser, so it's all byte set off, right? So we can't simply delete. We have to rewrite that file. So that again creates a problem. That's what the strategy. What uh, Iceberg follows is it creates a new pointer and an auxiliary file that records that what was deleted. And using this formats, Iceberg handles deletions efficiently and without requiring expensive rewrites. So there are two types of means there are two different major uh, ways or major, I will say, formats using which Iceberg maintains this. One is delete files, another one is deletion vector. Delete files are specialized files that track rollable changes or rollable deletions in Iceberg table. Deletion vector also does the same thing, but it does with an binary precision of deletes for a particular single data file itself. It is not so the deletion vector is tied to the data file. So let's talk about the delete file, how delete files work. So there are two types of not two types, but let's say what it will do is based on the table type, table property type. Like we can have merge on read, copy on write. There are two types of tables in Iceberg which are supported. So merge on read tables are ones which allow, which will use these delete files to handle the changes separately, and while reading it will be merged. So that's what it says, that if we want to use delete files for deletes, then we will have to set this merge on read true. Means this write mode as sorry, delete mode as merge on read. So there are three types of delete formats: position delete, equality delete, and deletion vector. Position delete and equality delete both are stored in files, while this is stored as a vector. And at a high level, what are the things, what are the aspects of these three is, uh, in positional delete, we use a separate delete file. In equality delete also, we use a separate delete file. But in case of deletion vector, we have a puffin file which stores the uh, deletion vector of a particular file. Row, it's not raw, it should be row identification, which is ROW. My mistake, it is RAW, but it should be row identification. So how position delete identifies a row that needs to be deleted is it provides the file path that, okay, this file, this particular data files and this row number needs to be deleted. In case of equality delete, what it stores is that it will store the primary key or column combination to identify uniquely a record. So let's say if we have said delete a record where ID is equal to 1, so that ID is equal to 1 will be stored in the equality delete file. In case of deletion vector, it is stored as a bitmap, so that is space efficient. Write latency, so positional delete, because we have to create a new file with the file path and the row number that needs to be deleted, so the write latency is very high. In equality delete, write latency is low because we are not trying to find the position. We are just saying that, okay, this is the key which needs to be deleted. So in case of position delete, we have to find the row number, right? So we have to first load the whole file and then calculate where is that row which satisfied the condition and that needs to be deleted. So that's why the positional delete latency is write latency is high. Equality delete it will be medium, and deletion vectors is very low because it just updates a vector map. Query latency in position delete is medium because while reading the file path, we simply skip the rows which are there. But in case of equality delete, while reading, after reading, we will have to, based on the primary key, we have to remove that. So slightly higher query latency than the positional delete in case of deletion vector, because that vectors are very much optimized. They can be loaded in memory and simply applied while reading. It has a lowest of what you called latency numbers in terms of querying that data. Maintenance overhead, positional delete has a low maintenance overhead because it sits in a separate file. We can simply go ahead and update that file. But in case of equality delete, there is slightly more uh, maintenance is involved. And in deletion vector, because it's vector, it is a well optimized format. It's the overhead of maintaining that is very less. Rewrite. So what happens? Does this position delete gets rewritten during compaction? So yes, what happens is during compaction, what will happen? Data file will be rewritten based on this deletion file. So the data file will be rewritten in case we have a deletion file. In case of equality delete, it does not do a rewrite, complete rewrite of the files. And in case of deletion vector as well, it also, because this is a vector update, we don't have to rewrite the whole file for this purposes. Use cases, positional is good for if we are doing batch ingestion, and in that, if we are deleting something, then it's good to use position delete because at that time we already have the data in memory, so we know the row numbers. Equality delete is good when we are doing a CDC or change data capture kind of scenario, and deletion vectors when we need high performance and fine grained delete options. That's where this the use case fits. Supported versions. So position delete is supported in both version V1 and V2. Uh, Equality delete is supported in version V1, V2 as well as V3, and deletion vector is a new thing which only is supported in version V3. When I say version V3, it is the schema version of Iceberg spec. So that's where these things are there. So let's take an example of how the positional deletes files will look like. So positional delete will say this is a Parquet file. Let's say for brevity I have just given 001, but it will have a bigger name. So I'm basically saying this is the data file. So it will I mean this is the data file path. So the positional delete will store the file path, and the position it will say for this file position number 0 needs to be deleted for the same file, position number 5 needs to be deleted for a different file called 6, position number 5 needs to be deleted. And Spark supports positional deletes, which is something to notice. Equality deletes these delete files mark rows for deletion based on the specific column values rather than the position itself. So that is something very unique. And Flink actually supports both positional as well as equity delete. Now, how it does it? It has this it has this decision flow graph that they use. So they load the delete message and check if the equality field column is there or not. If it is exist, position information is there in the sync operator, then it will use the positional delete. If the position information is not present, then it will use the equality delete. So it depends in the sync operator whether the position of that particular row is available or not. So that's how this uh, Flink supports both positional as well as equality delete, and they try to optimize the one which is giving a higher throughput and performance in case of deletes. So equality deletes, delete rows matching some values, positional delete row at the exact position in the file. So this is something which we can, from the mnemonics point of view, we can keep as a file. So in general, a delete file can have whatever the things can have. It can have the file paths and the position. If this is for the case where we are using a positional delete, in or in case in case of equality delete, we have the row field, which contains the value that identify which rows should be deleted. For example, it can be an ID needs to be deleted, then it will hold the ID of that ID value of that particular row. So that is in the row one. This will contains information on the so this is about the partition. So which partition? So let's say a certain partition of the data needs to be deleted. That partition information is kept in here. Sequence number to track the order of changes that has happened. So the sequence number in delete files indicates when the deletion was committed relative to the other changes in the data set. So this is also one thing that is noted, and this is for the purposes of, let's say, if we want to do time travel and we don't have the sequence number, then the sequence of events, if doesn't match, then the history creation will be different. That's why it uses sequence number to ensure that the files are read with the right set of operations that were right sequence of operations that were performed on top of it. Then comes the deletion vector. The deletion vector is a binary representation of the deletes for a single data file, and this resides in puffin files and just stores the information that which positions are needed to be deleted. So a set bit, so it uses a bitmap. So a set bit at a position P indicates that the a row at a position P in the file will be deleted. So each data file can have at most one deletion vector for or a given data file in a snapshot, and that new deletes, whatever is happening for that particular data file, will get merged with the existing vector position for this delete file. So what happens is, let's say we have enabled deletion vector is enabled. Let's say we are running on v3 spec of Iceberg, and let's say first time when we delete something, there will be initially there will be no deletion vectors. So first time we delete, it will create a deletion vector. Second time, if we delete the rows from the same file, then it will not create a new deletion vector. It will just update the existing deletion vector and just the reference of that. So that's how deletion vectors work. So this was it in this blog, that how Iceberg uses delete formats. The reason I have delete formats mentioned is we have delete files and deletion vectors. Delete files are of two types: positional delete and equality delete, and deletion vector is of deletion only one type, but that only available in v3. So yeah, that's it. If you like it, do share it, and have a nice day.